Hello everyone, I'm back with 11.2 and this one is really important. It's a long one. We'll actually finish about half today and later on Monday we'll finish the other half. So this time we want to know how can you write the augmented matrix of a system of linear equations and the other way around as well. That means from the augmented matrix, we want to write the system of equations. That means we want to see this in both directions. And later on, next week, we'll see how to perform row operations on a matrix and how we can solve a system of linear equation using matrices. Okay. So first of all, how can we define a matrix? The matrix is basically, it does look like this, where you will have several rows. These are different rows, okay? And these are columns. Several columns, okay? You will have several entries here. Let's say that will be row 1, column 1, row 1, column 2. Similarly, it will be row 1, column n. So if you have AMN, M is the row and N is the column, okay? All right. So from this type of formation, we want to see some properties of matrices, and we want to know how can we relate a matrix with a system of linear equation, okay? So for that, first of all, as I said, from a system of equation, linear equation, of course, system of linear equation, we'll see how can we write augmented matrix. And of course, then we'll see from the augmented matrix, how can you write the system of linear equation. Okay, let's start. Excuse me. So if you have a system of linear equation like this, 7x plus 8y equals -2. So that's a system of linear equation, right? You have two variables, x and y's, and you can solve it for x and y from these two equations. So that is a system of linear equation. All right. So the augmented matrix is in this format. Of course, it will have the matrix format, as you can clearly understand. So what we'll do, we'll actually take coefficients from or for each of the variables from each equation. So for x, the first one is 3, and for y, the second one, that's 4. Similarly, for x, in the second equation, it's 7, and for y, it's 8. You can see we are taking this first equation on the first row and the second equation on the second row. You see that? We are maintaining the consistency. As you can see, the x's are in the same column and the y's are also in the same column. Can you see that? Alrighty, but the work is not yet done. As we are looking for the augmented matrix, we want to draw a line like this, and then as you can see we have other values here. We'll actually copy that. So for the first equation it's -1, we'll write it in the first row. For the second equation it's -2, we'll write it in the second row. And again you can see we have maintained the consistency. The row and the columns are exactly the same as the problem we have. Okay, so that's your augmented matrix. Let's try one more example, all right, and see whether it could be complicated to write this augmented matrix, because it looks pretty easy, and it is actually, but if there is any complication, if there is any space for errors, we want to see that as well. So let's take a look at the next system of linear equation. 3x plus y minus z equals 0. 2x plus z minus 4 equals 0. And y plus 2z minus 7 equals to 0. So if you just copy the procedure here, your augmented matrix might look like this: 3, 1, -1, as we are just taking the coefficients, of course, 2, 1, -4, and 1, 2, -7. So if you just take the coefficients, this will look like this, right? But this is not right. This is wrong. So that means there is something you need to take care of, okay? The system needs to be in the ideal formation. What's that? If you have seen, I said here that all the x's has to be on the same column, all the y's has to be on the same column, and all the constant values has to be on the same column. And it has to be on the right hand side, okay? So that means we need to transform this system of linear equation into the ideal format first. Otherwise, we might do a mistake like this, okay? So first of all, we'll keep all the x's and y's and z's on the same column in a way so that it maintains consistency. So if I keep the 3x here, y and z, that's all right. There is no problem with the first row. For the second row, 2x, no worries about that. But then we have z. We don't have any y. But as I said, all of the x, y's, and z's has to be in the same column with, in their respective column. So we can actually rewrite it as 0 times y, and then we can write the z here. And of course, we want to write the constant term on the right-hand side. So if I change sides for this, it will be 4. Can you see what I'm doing here? That's what you need to do. Okay, that's a y, by the way. That's what you need to do. Otherwise, you might make a mistake. Let's carry on doing that. For the third one, we don't have any x. So we'll write as 0 times x, plus we have y, plus we have 2z, and if we change side for the constant term, it will be a positive 7. Now, as you can see, all the x, all the y's, all the z's, and all the constant terms are in their respective columns. Now we can follow the same procedure to get our augmented matrix. Let's do that. That's your matrix form. So we'll just take the coefficients, so 3, 1, -1, and the constant term, 2, 0, 1, and the constant term, 0, 1, 2, and the constant term. So clearly you can see it's different, and of course it's the right one. So the key point here, you need to transform your given system of linear equation into the ideal format first. Then you can copy that procedure. Okay? Now, does it make sense? All right. Now, we'll see what happens if the augmented matrix is given, and from that, we want to write the system of linear equation. So let's say this augmented matrix is given 1, 2, -2, -6, 12, 18, and from this, we want to write the system of linear equation. So you can clearly see we have 2 rows and 2 columns. So definitely our system of linear equation will have actually 2 different equations, and this number of rows determine how many equations we'll have, and number of columns determine how many variables we'll have. As you can see, we have 2 columns, so we can take x and y's as our variables, right? So if we have seen, we have avoided the variables and just taken the coefficients here. So we'll do the opposite. So we'll add, or rather include, variables now. -2y and equals to will be the constant value. Can you see what I'm doing? Just doing it in the reversed order. Pretty simple. For 2x, 0, y, and z, you're writing a 2, 0, and 1. So if you're given 2, 0, and 1, clearly you can write 2x, y, and z in the reversed order, right? So for 2 and -6, I can write a 2x and a -6y equals to 18. And that's your system of equation. Pretty straightforward. Okay. All right. So that's your system of equation and augmented matrix. Next, we'll see how can you write, or how can you operate a row operation. How can you calculate that? What can you do? What's the basic idea of that, etc. Okay. Now, that is a crucial thing. And in this operation, you'll see 1 or 2 problems from me. You'll get a couple of worked out problems in the file and a couple of more in the book as well. And you'll have plenty of exercises. But even before we start, my suggestion to you would be, I'd recommend this, you guys. This is highly recommended, that after you see this video, you see at least 2 or 3 more worked out problems, and at least practice 1, because often it looks like that you understand it, but when you actually try to do that, things might get difficult, things might look difficult. You might see that there are lots of rooms for making errors. Okay, so if you practice 1 or 2, you'll be actually identify how well you have captured the concept. All right. So first of all, we want to know what is a row operation. So our next topic is, of course, row operation. All right. So row operation can be done in the following ways. First of all, you can interchange the rows. It doesn't really harm the value of the system of linear equation, and simply you can see that from here, If you interchange the rows, it doesn't do any harm to your system of linear equations. Your values, your solution will be still the same, right? Even if you write this equation first and this equation second, this doesn't really make any difference. Okay, so we can easily interchange any two rows. Then we can replace a row by a non-zero multiple of that row. You'll soon see what does that mean. And we can also replace a row by the sum of that row and a constant non-zero multiple of some other row. So that means you can actually multiply one row by a constant, and again it will keep the value intact. Okay, and you can add that row with some other rows and it will still keep the value intact. Simply you can see that here, if I multiply this second row by 2, it will be 4x, it will be 12y equals 36. If I just multiply this row by 2, and again your value is actually the same. If you solve it with this row, you'll still get the same result. So multiplying one row by something still keeps your value intact. And if you add one row with any other row, still it keeps your value intact, because if you add this row with the first one and replace this row by the resulting values, again it will keep your value same. You can try that if you want, but I think it's quite visible. You can actually imagine this, right? Okay, now let's take one example and see how can we do row operations. Okay, all right. So let's take this example. Let's say 1, 2, -4, -6, 1, 8. Okay, so that's your augmented matrix. And we want to use row operation on this augmented matrix. All right. Okay. So if I do this row operation, -2 R1 plus R2, that means I'll first multiply row 1 by -2, and then I'll add row 2 with that, and I'll replace that new new values at the second row, in the second row. Okay, so first of all, before we do any further calculation, we want to know how does we can denote that, how can we express the operation we are doing in mathematical terms. So this R1 means row 1, this R2 means row 2. So as I said, you can multiply any row by a term, by a constant. So this -2 R1 means we are multiplying the first row by -2, plus R2 means we are adding R2 with that. And finally, the resulting value will replace that in the second row. Now, if I slowly do that for you, let's see how does it look. So first of all, as I said, I'll multiply the first row by 2, by -2 rather. So it will be -2 times 1. Okay. And as I said, I'll add the second row with that. So the second row, obviously you need to maintain consistency again. You need to add or subtract the same uh, the corresponding column values. Okay, so when you're adding or multiplying negative the first row by -2 and adding that with the second row, that means if you multiply this by -2 and if you want to add second row with that, that means you will actually add the corresponding column value. Let me write it for you first. So that's your first row rather. We'll not do anything with that. We are actually, what we are doing is we are replacing our second row by multiplying first row by -2 and adding second row with that. So we have multiplied. Let me erase this. Okay. Okay, so we are multiplying the first row by -2. That means we'll multiply each of these two elements by -2, and then we'll add the second row. That means we'll add these two with that. But the thing is, as I said, you need to use the corresponding column values. That means, of course, multiplying the first row by -2 means we'll multiply this by -2, as you can see it here. And then adding row 2 means we'll take the first column, first value from the second row. That means we are taking the corresponding column. Okay, so this will be +2. So as you can see, we have multiplied the first row, that is 1, multiplied that by -2, and we have added the second row, as you can see. That's only done for the first element. We need to do that for the second element as well. Again, we'll multiply the first row by -2. So -2 will multiply the first row. So we'll take -4. And then we'll add the second row. The corresponding column value is -6. That's it. So that means we are multiplying the first row by -2. That's it. That's what you can see here. And then we are adding the second row. We are adding the second row here. That's it. Can you see that? And as you can see, we are replacing all of this in the second row. So when you are working with the first element, it has to be in the place of the first element. When you are working on the second element, it has to be in the place of the second element. Same goes for the constant as well. So we'll multiply this. Let me use a different color. So -2 by multiplied by the first row element, and we'll add this second element, second row element, of course. That's it. That's the row operation. If you understand what I have done here, whatever I do in the next steps will be quite understandable, will make sense to you guys, because I'll actually repeat this same process over and over again. Only the row operation will be changed for different rows. The number I'll multiply will be changed. That's it. But the idea will be same. If you can understand what I've done here, you'll understand the next row operations as well. Okay, so re-watch this video again and again. Try to understand by looking at the file and the book as well. As I said, it's not that difficult, but again, if you start doing it by hand, then you'll see it often it can create confusions. Okay, so if I simplify it, so -2 plus 2 will be 0, and +8 minus 6 will be +2. -2 plus 8 will be 6. So from this, we have now reached this. Okay, so that's one row operation we have completed. And we can keep doing that until we can find the row echelon form. The row echelon form. Now, before we go any further, we need to know how does this row echelon form look like. Because again, as I said, to reach the or to get the row echelon form, we'll actually keep doing this row operations using different multiples, using different addition and subtractions, but we'll actually do the same thing. I mean, the idea will be the same, what we have done here. So first of all, we want to know what is a row echelon form. So a row echelon form is achieved when the first entry, the entry in row 1 and column 1 is 1. That means this guy is 1. Row 1 and column 1, this entry is 1. Okay, and only zeros below this. We will have only zeros in the corresponding column. Okay, the other row values in the first column, that means these entries will be 0. This guy will be 1, the rest on that column will be 0. All right, and from the next row, all the first non-zero entries has to be 1, and again only zeros can appear in the corresponding column. So for example, if I have a column like this, 1 0 0, let's say we have different values here, let's say we have a 0 here, let's say this in the second row we have a 1 in the third column. So what echelon for a row echelon form needs is the first non-zero element in each row. You can see in the second row, the first non-zero element is this. So this guy needs to be 1 as well. Let me repeat that. The first non-zero element in each row, from the second row, of course, starting from the second row, the first non-zero element has to be 1 as well. And again, any value in that column, this corresponding column has to be 0. That means this has to be 0 as well. Okay, we can have different values here, but the first non-zero element, first non-zero entry has to be 1. And we need to carry on doing this in a way so that if you move to the lower rows, the number of zeros will increase. As you can see, number of 0 here is 0. We don't have a 0 here. Okay. Number of zeros here is 2. Number of zeros here is 3. That means as you go down to the rows, your number of zeros will be increased. Okay. That means if you look at the non-zero entry at each row, you'll see the zeros before that will be the number of zeros, of course, will be bigger than the number of zeros in the previous rows. Okay, so we'll take one example, and soon I think this will make sense to you. Okay, soon you will see that we can actually get the row echelon form by doing multiple row operations. Okay, now let's carry on where we were. I'll write that here, 1 - 4, and I will try to achieve row echelon form from that. So 0 to 6, 0 to 6. I think that's the row echelon form, isn't it? 1 negative 4 1 0 to 6, 1 negative 4 1 0 to 6. Yeah. So as you can see, this guy is 1. That's all right. No problems with that. And below that we have a 0. That's all right as well. But in the second row, the first non-zero entry, which is this is not 1. We need to make this 1 somehow or other. And as we don't have the third row, if we had a third row, we needed to have a 0 below that as well, but that's out of our computation right now, because we don't have any third row. So all we need to make the row echelon form is to have this entry as 1, because as I said, we define row echelon form in a way so that the first non-zero entry at each row starting from the second one has to be 1. That means this guy needs to be 1, and anything below that needed to be 0. But again, as we don't have any other rows, we can actually avoid that, because that's not a case in our problem. Now the question could be, how can we make this 1? How can we make this 1? Can you see what I'm doing? So clearly, if I want to make this 1, I want to multiply the second row by a half, because I can clearly see if I multiply this by a half, this will give me 1. Can you see what I'm doing here? That's pretty simple. I'm just trying to make this guy 1, okay? And of course, whatever I do, I'll be doing on each row, because we are calling this row operation. So as I'm trying to make this 1, all I need to do is to multiply the second row by a half. Let's do that. So it will be 1, negative 4, 1. Okay. And the operation I'll be doing, my new second row, that's my new second row, will be excuse me, half of the second row, half of the previous second row, of course. So my previous second row is this. Now what I'll do, I'll multiply that second row by a half, and then replace that values as my new second row. So if I multiply 0 by a half, so 0 times half will be 0. I'll replace that here. That will still be 0, and we need to have that as well, because any value below this one needs to be 0, if you remember, right? So that's all right. And if we multiply this 2 by half, it will become 1. So we'll replace that here. We'll multiply this 6 by a half. So 6 times half will be 3. We'll replace that in the respective position. Okay. So that will be the row echelon form. We have finally achieved the row echelon form. As you can see, let me write it for you. 1, negative 4, 1, 0, 1, 3. As you can see, the first row, first column, the first entry of the matrix is 1. Any value below that is 0. And in the second row, the first non-zero element is 3, is 1 rather. So clearly it's the row echelon form. So that's how we operate row operations to get the row echelon form. We'll carry on from here to see how can we use row echelon forms to solve a system of linear equation. First of all, I'd recommend you guys to practice at least one or two. Before that, see a couple of workload problems as well. And I'll add one video link as well from YouTube, which will be really helpful. You can see that as well. See the book, see this video, see the video I'll be adding in the email, and then practice at least one or two and see and check, verify whether you have completely understood the concept. How can you operate? How can you do these row operations, multiple row operations to get this row echelon form? Okay, I'll see you next week. Take care.